Okay, defining the trigonometric functions for general angles. Now, with this part, effectively what we're going to be doing is we're going to be using our sine, cosine, tan, cosec, sec, and cot. And we're going to be writing a new way to write these ratios out. So we know from when we do trig in year 9 and 10 that sine theta is equal to opposite over adjacent. Cos theta is equal to, sine theta is opposite over hypotenuse, cos is opposite over adjacent over hypotenuse, and tan is opposite over adjacent. But how does that relate to an x and y plane? Okay, so how do I work out a trig ratio for a particular angle when I'm given points in an x and y plane? Okay, so that's what this little subtopic is going to be talking about. So let theta be an angle, positive or negative. Okay, so, we've got a ray. Let's shoot it out this way. And it is theta. Okay. What we can do is we can start by constructing a circle with center at the origin and any positive radius r. Can't have a negative radius because you can't have a negative radius in a circle. Let the ray corresponding to theta intersect at a point. So let's start off by drawing a circle, and I'm bloody happy with that circle, that's for sure. So here's our circle here, and my ray intersects this circle at a point P. Okay, so I'm going to call that point P. Now that can be any point. We don't know what it is, so we're going to define it as x and y. Okay, so it's some value past the x, okay, and it's some value up the y. Okay, so we don't know what the value is, and it could be a changing value as well. And I've completely screwed this up by doing that now, which makes my C out. It's alright, I can fix it up. So we're going to define it at some point past the x, some point past the y. Okay, so with this, we can now define our trig ratios, okay? So this point here, actually, it was probably better if I kept these lines in, to be honest, but this point here, so we know this point is, we know it is x distance in that direction there, yeah? And we also know that it is y, actually, you know what I'm going to do instead? Sorry, I'm going to do the same thing, but along here. We know that it is this far along the x-axis, okay? And we also know that this point here is this far up the y-axis, okay? So it's a fraction of the x part of the circle, and it's a fraction of the y part of the circle, okay? I'm just going to translate this y over here, okay? So the distance from the center, which I've called O for origin, and my point P is x along the x-axis and y along the y-axis. So, say my radius r was equal to, say r was equal to 4, then x might be 3.2 and y might be equal to 2.1. Something like that, okay? It's not going to be exactly like that, but let's say it was something like that, okay? So we've got a radius r, and we've got a distance in the x-axis x and a distance in the y-axis y. Okay, we can define our trig ratios, our 6 trig ratios: sine theta, cos theta, tan theta, and we can also define our new ones: cosec theta, sec theta, and cot theta, using this this circle and this new triangle, okay? So that's a right angle in there because we've made a right angle triangle. The only thing we're missing is this length of this ray from the O to the point. And because it's from the center to the outside of the circle, well, it's the same as the radius of the circle. So it is the radius. Okay, now using that, we can now define our trig ratios along this circle, okay? So sine is opposite over hypotenuse, so the opposite is y, the hypotenuse is r. So it is y over r. Cos is adjacent over hypotenuse, so x over r. And tan is opposite, which is y, over adjacent. And remembering our cosec, sec, and cot are just the reciprocals of these, so r over y, r over x, x over y. Okay? So that's it. That's how we define the trig functions for general angles. Okay? So why is that useful? Okay, so it is useful so that we can, well, it's useful because we can now actually use our trig ratios to find angles of sines or of things that are bigger than, we can find our trig ratios for angles bigger than 90 degrees. So before we only dealt with between 0 and 90, and even then we didn't even deal with 0 and 90, so between 0 and 90, now we can deal with everything, okay? So just like we were looking at the rays for numbers that were between 0 and 360 and negative and bigger than 360, we can do the same for this. Okay? So a quick way to think of our x, y, and r as well, I'll just add over here. So in this case, x always will be with the adjacent. Okay, y is always going to be the opposite, just for when you do your trig ratios, and r is always the hypotenuse. Okay, so you can keep that in mind for when you need to make your right angle triangle. So what we're going to look at now is an example of how this is applied. Okay, so we've got a circle here that has a radius of 15 degrees. Okay, and the ray that we've got intersects a point at -9, -12. So using the definition, sine theta is equal to y over r, cos theta is equal to x over r, tan theta is equal to y over x, what we can do is we can write down the values of the 6 trigonometric ratios of the angle theta in the diagram. We're not asked to find what theta is equal to because we're going to do that later on. We're just asked to find what the ratios are. So this is like kind of like the intro to trig lesson that you do in year 9. So let's start off with sine. Sine theta is equal to y over r. So y in this case is the difference in the vertical, okay? So that is the second part of the coordinate. So this one is -12. So sine theta is equal to -12. In fact, you can write your information over the side here. So using this point, so this coordinate, I know that's x and that's y. So x is equal to -9, y is equal to -12, and the radius is 15, okay? All you have to do is just put these numbers into these ratios. That's pretty much all we're doing for this part. So sine theta is equal to, so y over r, so -12 over 15, and that's it. Okay, -12 over 15, done. Cos theta is equal to -9 over 15, and tan theta is equal to, okay, so this one, it is -12 over -9, but that just turns into 12 over 9, okay, because the two negatives cancel that. Then we're going to do our new one, so cosec theta, and that's equal to, well, that's just 15 over -12, or -15 over 12, okay. Sec theta is equal to -15 over 9, okay. And cot theta, well, if tan theta is equal to 12 over 9, cot theta must be 9 over 12 because it's just the reciprocal. Okay, that's pretty much it for this one. Now, the other thing that we're going to talk about is the boundary angles. Now, boundary angles are special in the fact that with your boundary angles, they are these points on here. So we've got one at 0 degrees, one at 90 degrees, one at 180 degrees, one at 270 degrees, and every multiple of those. So like -90 degrees, -180 degrees if you're going backwards, or 360, so 360 degrees, 450 degrees, etc. And going back, -90 degrees, -180 degrees, etc. So those are our boundary angles. So they're the ones that are right on the line. Okay? So the value of the boundary angles changes depending on, or they're defined depending on what, or where they are, effectively. Okay, so let's have a look at a little table. Okay, so what we're going to do is we're going to draw up a new one, like just over here. Okay, so we've got, so it's radius r, minus r, and minus r, because that's how big our thing is. So the points at these values here, so the coordinates at those ones here are r0, 0r, this one is minus r0, and this one down here is 0 minus r. So that's going to help us work out what our sine, cos, tan, and cosec, sec, and cot are for these boundary angles. Okay, so remembering that this is 0 degrees, 90 degrees, okay, 180 degrees, and 270 degrees. Okay, so theta is 0, 90, 180, 270, and then after that it just repeats the pattern again. So this pattern basically keeps repeating. So my x at 0 degrees is just this value in here, which is r. Okay, my x at 90 degrees is 0. My x at 180 is negative r and 0. Okay, that's all it is. So my y value, so my y ordinate at 0 degrees is 0. At 90 degrees it is r, 0 minus r. Okay, and my r, okay, so my r length is always r long. Okay, so no matter which part of the circle I'm on, okay, is it 0, 90, 180, or 270, the distance from here to there, so we're talking about distance, okay, is always just as long as the radius is. Now we can use these boundary angles to work out what sine theta, cos theta, and tan theta are, and then we'll do sec, cosec, and cot after this. So sine is defined as, back over up here, sine is defined as y over r, so y divided by r. So 0 divided by r, well, that's just 0. So sine theta at 0 degrees is equal to 0. And you can put that into a calculator to test it. Try typing in sine of 0, and it'll give you a value of 0. Let's put 90 degrees in. Okay, so it's y over r, so r divided by r. So anything divided by itself is just equal to 1. And you can test that again too by putting, if you put sine of 90 degrees into a calculator, you will get an answer of 1 back out. 0 divided by r is just 0 again. And now this one, negative r divided by r, well, negative divided by a positive is negative, and then r divided by r is 1. Okay. Now cosec is defined as x divided by r. So r divided by r is equal to 1. 0 divided by r is equal to 0. Negative r divided by r is equal to negative 1. And 0 divided by r is equal to 0. Now with this one, it looks like they've all just been pushed across 1 for the sine. And as a matter of fact, they have been pretty much. Okay, now we're going to do tan. So tan is defined as x over y, I believe. Y over x, sorry. So 0 divided by r, well, that's 0. R divided by 0. Now, this is where we get tricky, because we can't divide by 0. So in fact, it is actually undefined at 90 degrees. If you put tan of 90 degrees into a calculator, you will actually get a math error because you can't do it. And this is the reason why, because your ratio between your sine, your ratio of tan is the x part and the y part, okay, of a ray. So how far to the right or left is it? And then how far up or down it is. Okay, so if it's straight up, there is no, well, it's not defined in any way, shape, or form, which I think is really cool. So I'm going to put a star there to signify that. Continuing on, y divided by r, 0 divided by negative r is just 0, and r divided by 0 again, well, that was also undefined. Doesn't make a lot of sense for that one, but you will see in the next video when we actually have a look at what these pictures, well, what happens when we put this all together, you'll see some stuff that's really, really cool. Anyway, let's continue on. We're going to do our inverse. So we're going to do cosec. We're going to do sec. And we're going to do cot. So cosec is just the opposite. So when we did y over r for sine, we're going to do r over... So in this case, this one is not defined at all. Okay, so we can't actually define this one. Okay, this one here is going to be... well, this one is r divided by r again, so this one's 1, so it's the same as what sine would be. Okay, this one here is going to be undefined again, and this one's going to be -1 as well. Okay, so if we compare that to sine, so if we compare cosec to sec, because remember cosec is just the reciprocal of sec, if sine is 0, it's undefined in cosec, whereas if it's 1, it's also 1. So we're going to be using that fact to be able to do the sec one very quick, because remember, sec and cos are the ones that are related. So if it's 1, it's also 1. If it's 0, it's undefined. If it's -1, it's also -1. If it's 0, it's also undefined. Nice and easy, and you can use the definition to fill that in if you want to. Now, cot. Cot's the funny one. If it's 0, it's undefined. If it's undefined, then it's going to be 0. And it's basically just the opposite of what we've got in tan. So if you have a look at tan, 0, undefined. Undefined, 0. 0, undefined. Undefined, 0. Okay? So that's what, if I was to put sine of 90 degrees or 1 over sine of 90 degrees, like these are the values that you get out in return. Okay, we're going to be looking at the other angles later on, but you guys already know sine of 30, cos of 60 degrees, tan of 45 degrees. These are just some more ones that we're going to add to our repertoire. 0, 90, 180, 270. These ones are a lot easier than 30, 60, and 45, but they're still ones that we need to remember. And they're very, very useful for a lot of things. Okay. So with that being said, our next video will be looking at the trigonometric ratios, okay, and the graphs of what they look like, okay. So I will see you guys in the next video.